Section 1.3 is on the transformation of functions. Before we can talk about transformations, we have to talk about some of the parent graphs that we will be discussing throughout the chapter. This chart is in your textbook in section 1.6. If you will go to your ebook, which is under chapter contents in my math lab, you should be able to find this page that has Algebra's Common Graphs on it. You can print it from your ebook, or you could just use it as a reference if you want to. But the first two functions are linear functions. This is our constant function, the horizontal line. The equation is f of x equals c. The domain is all real numbers. The range is just the constant value of c. And this is an even function because it is symmetric about the y-axis. The second function here is called the identity function, which is just a straight line. The equation is f of x is equal to x, or y equals x is another form. The domain and the range are both all real numbers. It just has one increasing interval from negative infinity to positive infinity. Now, this is an example of an odd function where it is symmetric about the origin. Okay, the next equations that are not linear, they're not lines, that you may not be as familiar with. The first one is the absolute value function. And so the equation for this is f of x is equal to the absolute value of x. Okay, it's not curved like a parabola, it's just a V shape. The domain is all real numbers, but the range is from 0 to positive infinity. And then we have a decreasing interval from negative infinity to 0, an increasing interval from 0 to positive infinity. And this is an even function. Okay, the standard quadratic function, which we call the parabola, the equation is f of x is equal to x squared. And like I said, this is the parent function. This is the graph of just f of x equals x squared. Domain is all real numbers. Range is from 0 to positive infinity. We have a decreasing interval, increasing interval, just like you do for absolute value. And this is also an even function. Okay, the next one is called the square root function, and the equation is f of x is equal to the square root of x. And now the square root function always has this shape. Okay, it's kind of like half of a parabola that's been turned over. Okay, kind of look at it that way. It starts at the origin. We have a point here, so my domain is 0 to positive infinity. The range is 0 to positive infinity also. This is an example of a function that's neither even nor odd. It doesn't have any symmetry. Okay, the standard cubic function, the equation is f of x is equal to x cubed. It's kind of like a parabola in the sense you have this right half that's increasing, but if you can imagine if you had a parabola on the other side, but it's just been flipped down. Okay, so we have this curved S shape for a cubic function. Domain and range are both all real numbers, and this is an odd function. And the last one is the cube root function. The equation is f of x is equal to the cube root of x. Similar to the cube function, domain and range is all real numbers, and this also is an odd function. Okay, I went over these just so you could see the shapes. The main ones that you'll see probably the most will be like the absolute value function, the parabola, the square root function, a little bit with the cubes. Okay, you need to be able to identify these parent graphs. Okay, that these are the original graphs for these shapes. So you should know the names and kind of, just what the graph looks like. In the next part, we're going to be looking at vertical and horizontal shifts of these graphs as well as reflections of these graphs.